Good morning, statistics class. All right, I'm going to go over this worksheet that you were supposed to get for homework, 7.2C and 7.2D. These were actually quizzes that I just gave as homework, kind of to give you a little bit more practice on chapter 7.2. All right, the first one, a Department of Energy official has suggested that the following probability model for the type of fuel used for heat in residential homes in Maine. All right, notice two things. You have to explain why this is a valid probability model. And the two answers are, make sure that each one of these probabilities are between 0 and 1. If you see a negative, which means it's below 0, or anything above 1, then it's invalid. The other thing is you got to make sure that these add up to 1. 0.1 plus 0.3 is 0.4, 0.4 and 0.4 is 0.8. This makes it 0.9, and this makes it 1. So make sure it falls within these two guidelines. Second, what is the probability a randomly selected home is heated with oil or coal? In this type of case, you're not using probability of A plus the probability of B minus the probability of A and B. This isn't a two-way table. Okay, so you simply just add the oil and the coal together. So the oil is 0.1, the coal is 0.05, added together you get 0.15. What is the probability a randomly selected home is not heated? Well, if you take, heated with electricity, so if you take this out of the mix, it's everything else. The other method is just take this whole thing adds up to 1, so 1 minus 0.4 is 0.6. Second question. In a statistics class, there are 18 juniors, 10 seniors. 6 of the seniors are females and 12 of the juniors are males. Okay, here is your two-way table. Notice I got juniors, seniors, female, not female. You could actually put males here. It doesn't really matter. But notice 18 juniors, 10 seniors. Those are my totals. And then, of course, 6 of the seniors are female and 12 of the juniors are male. So it kind of helps you build your two-way table. Make sure all the totals add up. Now, a junior and a male. Well, if you have a junior and a male, that's this intersecting point right here. So 12 out of a total of 18 gives you 0.429. Remember to reduce it if you're going to leave it as a fraction. A senior or a male, okay, here's your addition formula. So since it's or, it's the probability of A, which is your senior, plus the probability of your female, minus the intersection, because you don't want to count it twice, and that gives you 16 over 28, which reduces to 407, which is 0.571. A junior or a female, same thing. The probability of a junior is 18 out of 28. The probability of a female is 12 out of 28. You add those together and you subtract the intersection because you don't want to count it twice, and you get 0.857. Someone other than a senior female. Well, here's a senior female right here in this little section right here. So that means you could actually add the 6, the 12, and the 4. And that comes out with 22 over 28. Or you can just do 1 minus the 6, or 28 over 28 minus the 6 over 28, and that gives you 22 over 28, which is 0.786. Finally, on the next side, on 7.2D, you have this chart here. Also, there's a note here, answers may be left in fraction form. Again, I prefer to have decimal form. So probability of a junior, you go all the way to the end, 635 out of the total is 0.241. A senior who eats in the student center, so you go to senior, student center, that's that intersecting point right there, so 280 out over 2640, 0.106. A freshman who doesn't eat in the student center, so here's the freshman. That means I'm going to add this one and this one together, so that's 110 plus 435, which is 545 over 2640, which is 0.206. Now here's your intersection, or an or statement, a sophomore or a junior who eats in the small cafeteria. Now in this case, this is not one or the other. It's a sophomore or junior who eat in the small cafeteria. So if you look at the small cafeteria, sophomores and juniors, that adds up to 425, and that's what you have to do. 425 over 2640 is 0.161. On E, this is your addition rule. Probability of A, that's your senior, or someone who eats in the large cafeteria. So it's either one or the other. So the probability that is senior is 635 over 2640. Someone who eats in the large cafeteria is 1085 over 2640. Subtract the intersection, you get 1370 over 2640, which is 0.519. And then finally, the last question, there are 2 traffic lights. Okay, so here's traffic light number 1, which is your first light. Traffic light number 2, which is your second light. This is stops at the first light, doesn't stop at the first light. F is stops at the second light, doesn't stop at the second light. When it gives you these, you can actually build a Venn diagram as well. But suppose that E is 0.4, so that means E, that's the total, is 0.4. The total of F, which is stopping at your second light, is 0.3. Well, remember, your whole thing has to add up to a probability of 1. So 1 minus 0.4 is 0.6, and 1 minus 0.3 is 0.7. So now you have your totals. Now here's your intersection of 0.15. Stops at both lights. And then from there, you can just use subtraction to fill in the rest of it. All right, problem A, must stop for at least one light. Well, it has to stop for E, which is 0.4, has to stop for F, which is 0.3, but you subtract the intersection here because of stopping at both, so therefore it's 0.55. Doesn't stop at either light. Well, if it doesn't stop at E and doesn't stop at, or first light doesn't stop at second light, that's that intersection right there, 0.45. Must stop at exactly one light. Well, that means it'll stop at E but not F. It'll stop at F but not E, so you just add those two together. And that's 0.25 plus 0.15, which is 0.40, and must stop at the first light. All right, well, if it must stop at the first light, your first light is E, so it comes straight down. That means it doesn't stop at F, so 0.25.